Hello everybody, hope all of you are well and hope all of you are maintaining the 6 feet distance in public places. Always you wear mask when you are in public place. Frequently you wash your hand with soap water, okay, so that together all we can win, okay, the fight against the COVID-19. Today I'll first discuss your pre-annual unit test syllabus, okay, that will be held in the middle of the December, okay. So your pre-annual unit syllabus for class 12 science is coordination chemistry, D and F block elements. Next one is surface chemistry. Next one is chemical kinetics, aldehydes, ketones, carboxylic acids, organic compounds containing nitrogen, and biomolecules. Okay. So already you have completed the coordination chemistry, chemical kinetics, aldehydes, and your new chapters are that today I will discuss that organic compounds containing nitrogen. Then we will discuss biomolecules. After that, if we get time, we will discuss the surface chemistry. So, all of you know that alkyl derivatives of ammonia are known as amines. Depending upon the number of the alkyl groups, amines can be classified into different categories. When one alkyl group is attached with this amine group, then it is called 1 degree amine or it is called primary amine. Primary amine. When there is 2 alkyl group attached with this amine group, then it is called 2 degree amine or it is called secondary amine. When 3 alkyl groups are attached with this amine group, then it is called 3 degree amine or tertiary. Tertiary amine, okay. Now, when aromatic groups are attached, then it is called aromatic amine. Suppose one benzene group is attached to this amine group, then we can tell it that aromatic amine, okay. Aromatic amine. Now regarding the nomenclature, aliphatic amines or amines are named as alkan amines. Okay. Suppose if we write CH3NH2, what will be the IUPAC name of this amine compound? This will be the methanamine. Methanamine. Okay. If we write structure of amine like this, this one is 2 methyl group and 1 ethyl group is attached. Okay. So the name of this amine will be that N dimethyl ethanamine. N dimethyl ethanamine. These are the IUPAC nomenclatures of amine. Next we will discuss the preparation of these amine types of compounds. First one we will discuss from alcohols. From alcohols. When the vapors of alcohol and ammonia is passed over heated alumina, that means Al2O3, around 723 Kelvin, a mixture of primary, secondary and tertiary amines are obtained. So here we are taking the first ethyl alcohol and we are using ammonia and as a reacting agent we are using Al2O3, aluminium oxide, alumina, and temperature we are maintaining around 723 Kelvin and there will be elimination of water, we will get C2H5NH2. So in this way we will get the amine. In next step what will happen? This will again react, that ammonia and L2O3 at 723 Kelvin. Again there will be formation of C2H5 NH C2H5. That means diethylamine. Okay. The same way, here you have to use the alcohol also. Amine is there, but you have to use alcohol. And in C2H5 OH you have to use. Then you will get this one. And in the next step, you have to give again C2H5 OH and Al2O3, and you have to apply heat around 723 Kelvin. Then you will get the triethylamine. So in this way we can prepare amines from alcohol. So the reaction will not stop here. If we take this alcohol excess, then this amine, primary amine will convert it into secondary amine, and the secondary amine in presence of alcohol will convert it into tertiary amine. Okay. Next we will discuss another procedure for amine preparation. This is from alkyl halides. Alkyl halides. So in case of alkyl halides, the type of the method or reaction is called Hofmann's ammonolysis method. When alkyl halide is treated with an alcoholic solution of ammonia, a mixture of 1 degree, 2 degree and 3 degree amines along with a quaternary ammonium salts will be obtained. So here suppose we are taking that CH3Cl and ammonia. Okay. So here temperature is required around 370 Kelvin. It will form CH3 NH3 plus Cl minus. Okay. In this next step, this CH3 NH3 plus Cl minus will react with another molecule of ammonia, and this is a reversible process, and you will get the primary amine, and there will be formation of ammonium chloride. So in this way we have to deprotonate this salt, okay, by using this ammonia. So you can understand. So in this way we can prepare the 1 degree. Here also we will get mixture. If there is still methyl chloride, this methylamine will react with this methyl chloride. That is CH3NH2 will again react with this methyl chloride at around 373 Kelvin. Okay, it will form CH3N CH3H2 plus Cl minus. In the next step, this CH3N HH plus CH3 Cl minus react with ammonia and make it the amine free. We get that secondary amine. Plus there will be formation of NH+. Okay. In the next case, this amine again will react with this dimethyl amine, okay, or that means secondary amine will react with this methyl chloride. That's CH3 N CH3 NH will react with CH3Cl forming NCH3 CH3. This is substitution reaction. Maybe SN2 type of reaction. plus Cl minus. And in the next step, this CH3, NCH3, CH3 plus Cl minus react with ammonia, and this reversible reaction will form the tertiary amine. Plus NH4C. And in the last step, this tertiary amine will also react with this methyl chloride and forming the quaternary salt, quaternary amine. So in this way, we will get a mixture of 1 degree, 2 degree, 3 degree and quaternary amines. So it is difficult to separate the individual amines from the mixtures. That is why this method is not preferred. Next we will discuss preparation of amine from cyanide. From cyanide, if we take RCl and if we add one reducing agent like lithium aluminum hydride, it will form the corresponding primary amine. Okay. So in this way we can get that 1 degree amine. But if we take isocyanide, that means if we take RMC, then if we use the same reagent, then what we will get here? Here we will get the 2 degree amine. Okay. So if we take the alkyl cyanide, okay, we add lithium aluminum hydride, then we get the 1 degree amine. But in case of isocyanide, we will get the 2 degree amine. Next we will discuss the preparation of amine from nitro compound. If we take any nitro compound, that RNO2, and if we add the reducing agent tin and concentrated HCl, and there will be reduction of this nitro group, that will form also amine group, okay, and formation of twice. So in this way also we can prepare the amine group. But the best method or very good method for the preparation of primary amine is Gabriel-Thalamide reaction. Gabriel-Thalamide reaction. Now in this Gabriel-Thalamide we have to use thalamide. This one is the phthalic anhydride or thalamide, prepared from phthalic anhydride by reaction with ammonia. Then we have to abstract this proton by using potassium hydroxide, alcoholic potassium hydroxide. So if we give alcoholic potassium hydroxide, there will be emission of water, and this proton will be taken by this OH minus ion, and we will get the corresponding solid or amine. Okay, in the next step we will give the corresponding alkyl halide. Give C2H5 here, then what will happen? There will be SN2 reaction. The alkyl group attached with this nitrogen. And next step we have to hydrolyze this amide group by using 20% dilute HCl. Okay. We give dilute HCl and water, we hydrolyze, then we will get the primary amine, C2H5NH2, and this will be converted into phthalic acid. Now this salicylic acid again can be used for the preparation of phthalamide. Okay. We have to heat it, then first there will be formation of phthalic anhydride, elimination of water by reaction with ammonia, we will get back this phthalamide. So this is the best method and here yield is very good. So in this way we can prepare different types of amine compounds. So these methods are given in your syllabus. That is, these methods you have to read properly. Next we will discuss the physical properties. Okay. Lower members of this amine like methylamine, ethylamine, dimethylamine, okay, these are gases. But if we think about the higher amines, higher members are liquids. Amines have higher boiling points than alkanes, but lower boiling points than alcohols. This is because weaker hydrogen bonding in amines than alcohol. When we are considering the alcohol, there will be intermolecular hydrogen bonding, so that will be the strength of the hydrogen bond will be higher because oxygen is more electronegative than nitrogen. But in case of amine, it will be lower. Okay, strength of hydrogen bond will be lower. Next one is the different types of amine like 1 degree, 2 degree, and 3 degree. What will be their boiling points? Okay, generally 1 degree amines have higher boiling point, then 2 degree amine, then 3 degree amines. The boiling points. Now what is the reason that boiling points of primary amines are higher than the secondary amines and secondary amine is higher than tertiary amine? This is because of the large tendency of primary amines to form hydrogen bond than other types of amines. Okay, with the increase of number of alkyl group with nitrogen, the extent of hydrogen bonding decreases. Okay, that is why primary amine has the highest boiling point. Okay, or boiling point of primary amine is higher compared to the secondary. And now if we think about the lower members of amines, they are water soluble. Why amines are water soluble, lower amines? Because they will form intermolecular hydrogen bonding with water. Okay, but if we increase the chain length, then because of this hydrophobic effect, the solubility will decrease. Next we will discuss the chemical properties. Now first we have to understand that amines are very good Lewis bases due to the presence of lone pair of electrons on nitrogen atom. Okay, so we know that Lewis bases are electron pairs donors. Okay, so that is why amines are very good bases. Okay, and the better the ability to donate the lone pair of electrons, greater will be the basic strength of the amines. Basic character of amine depends on the different types of factors. First one is inductivity. If we increase the inductivity, then definitely basicity will increase. If we increase the number of alkyl group on nitrogen atom, okay, definitely the basicity will increase. So higher the plasticity effect, higher will be the basic character. Next one is solvation effect. Higher the solvation, higher will be the basic natures of amine. Okay, solvation means there will form hydrogen bond and there will be release of energy. Definitely the basic nature of the amine will increase. But if you think about the steric effect generally decreases the basicity of amine. Okay. Next we can think about the resonance. If the lone pair of the nitrogen is engaged with the resonance with benzene ring, definitely the basicity of amines will decrease. That is why we can think about the aromatic amine and aliphatic amine. Okay. Aromatic amines, the nitrogen lone pair is taking part in the resonance with the benzene ring, there is a basicity will decrease. But aliphatic amines, because of the plus I effect and as it is not taking part in the resonance, okay, so aliphatic amines will be stronger base. Now aliphatic amines are stronger base than ammonia. This is also because whenever we are adding one alkyl group to this ammonia, definitely it will be the aliphatic amine. Okay. Now the decreasing order of the basicity of amine will be the tertiary amine. Tertiary amine is the highest basic. Okay. Next is the secondary amine. 2 degree amine. Then 1 degree amine. Then ammonia. And whatever we are here thinking, that is in gas phase. And if we use solvent, then we have to use aprotic solvent like CCl4, carbon tetrachloride, carbon disulfide. So in aprotic solvent, aprotic, but the scenario will change whenever we think about the basicity of amine in aqueous solution. Basicity of amines in aqueous solution. If we think about the methylamine, so Me2NH, this will be the highest basic. Okay. Next will come the primary amine. Okay. And next will come the tertiary amine. Next will come the ammonia. So basicity is highest in aqueous solution in case of secondary amine, in case of Me2NH. But if we think about the ethyl group attached with the nitrogen of amine, then Et2amine, that means secondary amine basicity will be the highest. Then Et3N, triethylamine is coming. Then the primary amine will come, ETNH2, then amine will come. Okay, here actually in case of this secondary amine, why basicity is highest? Because whenever there is in aqueous solution, it is forming hydrogen bond. We are thinking about this is the base, this is the conjugate acid. When it attached with one proton, so this is stabilized by hydrogen bond with water, and there will be as well as +2 inductive effect, I effect. Okay, 2 inductive effect, that is stabilized. Okay, so here mainly solvation as well as plus I effect, and hydrogen bonding is operating. Okay, and summation of this effect will determine which one will be more basic. So this order you have to remember, this is very important for examination. Okay, Me2NH will be the highest basics. They are both inductive effect and hydrogen bonding, and the solvation energy will be the highest. Okay, that is why this Me2NH and Et2NH in aqueous solution will be stable. But if you think about the gas phase always tertiary amine is highest basic because of the plus I effect of this alkyl group. Then secondary amine, then primary amine, then ammonia will come. Next, if you think about the aromatic amines, aromatic amines are less basic, okay, compared to the aliphatic amine. Okay, if we think about the pKb value, then you can easily understand. In case of aniline, when NH2 group attached with a benzene ring, here pKb value will be around 9.38. But when it is attached with an alkyl group like C2H5NH2, here the pKb value of this ethylamine will be around 3.29. So at the lower pK value means higher basicity. In case of this, actually here this nitrogen lone pair is engaged with the resonance this benzene ring. That is why it is not free to donate. Okay, actually if the lone pair or nitrogen atom is easily available for donation, then it will be the higher, it will show the higher basicity. And here what is happening, this lone pair of nitrogen is not taking part in resonance, as well as this ethyl group has plus I effect, that is increasing the electron density on this nitrogen atom. That is why it is highest basic compared to this aromatic amine. Okay. Next, we will discuss the effect of substituents on aromatic amines. Okay, if we add some substituent, then what will happen? Suppose we know that this is the aniline, pKb value around 9.38, but if we add one electron withdrawing group, then what will happen? Like nitro group if we add. Generally nitro group will pull the electron, okay, so definitely it will decrease the basicity, and here pKb value will increase, pKb value will be around 13, okay, but if we attach one electron releasing group like methyl group, what will happen? Definitely electron releasing group will increase the electron density on the benzene ring and make the amine nitrogen, okay, better donation, availability of nitrogen lone pair will be or donation of nitrogen lone pair will be better, okay, when there is electron releasing group, okay. So the electron releasing group will increase the basic strength of this amine, that you have to remember. Next we will discuss the alkylation of these amine compounds, replacement of hydrogen from amine by alkyl group. So alkylation, if we take the primary amine like CH3NH2, then if we give CH3Cl, this will attack here, there will be SN2 type of reaction, bimolecular nucleophilic substitution reaction, and here we will get the secondary amine. If there is methyl chloride excess, then this secondary amine will also react with another methyl chloride, and there will be formation of tertiary amine, and again this tertiary amine will react with methyl chloride to form the quaternary amine. Okay, so in this way we will get a mixture of primary, secondary, tertiary and quaternary. Next we will discuss the acylation reaction. So if we give acetyl chloride to this amine, acetyl chloride can be easily prepared. We have to take acid, and if you add any chlorinating agent like thionyl chloride, PCl5, okay, PCl3, then there is formation of CH3Cl, COCl. Here also this will attack here, and this chlorine will leave, and we will get the CH3 NH okay. So nitrogen of this amine will be acetylated by using this acyl chloride. If we take secondary amine, also there will be acylation. Okay. Next we will discuss the reaction with nitrous acid. Reaction with HNO2. We know that nitrous acid can be easily prepared by using NaNO2 and dilute HCl. Okay. In case of primary amine, whenever we use nitrous acid, and here temperature you have to maintain 0 to 5 degrees, this amine group will be converted into alcohol, and there will be formation of nitrogen gas and water. Okay. But if we take the secondary amine, what will happen? R2NH, and there this nitrous acid will react, and there will be N-nitroso dialkyl amine compound. Okay. So here we get that R in R NO. This type of compound we will get. Okay. But whenever we will take the tertiary amine, then what will happen? If we take R3N, and here if we add this nitrous acid, then what will happen? There will be formation of R3NHNO2. Okay, there will be formation of this thing, that salt will form. Okay, this plus, this minus, and then by applying it we will get the alcohol, and same nitroso type of compound, N-nitroso type of compound. Okay. Next one, a very important reaction by which we can easily detect the primary amine. Only primary amine will respond to this test. This is called carbyl amine reaction. Already we have discussed in case of haloalkanes. Okay. So this is carbyl amine reaction. So in carbylamine reaction, we have to take only the primary amine. Primary amine will respond to this test. Then we have to take chloroform plus alcoholic KOH. Okay, thrice alcoholic KOH is required. Then we have to apply heat. Then there will be formation of an obnoxious smell. Okay, of alkyl isocyanate. The smell of this compound will indicate that there is primary amine. But we should not perform this test in our laboratory. There are different tests like backdiet test, by which our Lieberman test is there, by which we can identify the amines. Okay. So generally this test is not done in the laboratory. Okay, for safety purpose. If you prepare this type of isocyanate compound, then you have to use concentrated acid to decompose this compound. Okay, and you can take the smell only by putting your thumb on the test tube. Okay, and then you take the smell, and you will get a very bad smell or extremely unpleasant odor. Okay, and by this reaction you can easily identify that there is primary amine. Okay, and secondary and tertiary amine do not respond to this test. Next we discuss one very important separation method that is included in your syllabus. Okay, there are other methods also, but this is very important for your syllabus. That is called Hinsberg separation method. Okay, from primary, secondary, and tertiary amine. Okay, Hinsberg method. Hinsberg method. Now in Hinsberg method, there will be one Hinsberg reagent. This Hinsberg reagent is benzene sulfonyl chloride. This one is the Hinsberg reagent. In this method, amine mixture is treated with benzene sulfonyl chloride, and the solution is made alkaline with aqueous KOH, and some ether is added. Primary amine gives the N-alkyl benzene sulfonamide, which forms a water-soluble salt with KOH. So this reagent will react with this primary amine, R-immunity, and there will be elimination of HCl, and we get C6H5 SO2, okay, NHR. Okay, in the next step we have to add KOH. So this proton is acidic, so KOH will take this proton. Now this compound is soluble in water. So primary amine will react with this Hinsberg reagent, and there will be formation of this sulfonamide, N-sulfonamide. Okay, and when you will add potassium hydroxide, okay, then aqueous solution of potassium hydroxide, that will form a soluble water soluble salt. Okay, and secondary amines from N-dialkyl benzene sulfonamide. Okay, and this does not form a salt as there will be no hydrogen. Okay, with alkali, and is insoluble in water or water KOH solution or alkaline solution. Okay, so secondary amine, like we can think about that this C6H5 SO2 Cl will react with R2Na. Okay, and there will be formation of this sulfonamide, C6H5 SO2 NRR, as there is no minus HCl, as there is no hydrogen, so it is insoluble, it is not it will be not soluble in KOH solution. Okay, so it is insoluble in alkali. Hope you can understand. And in the next case, that means tertiary amine. Tertiary amine does not react with this Hinsberg reagent. Okay, so in the first we have taken that ether as well as the aqueous KOH solution. So if we pour the whole solution in a separating funnel like this, so in the lower layer will be the aqueous layer. This is the aqueous alkali layer. Aqueous layer. And the upper layer, that is the ethereal layer, organic layer. Ether layer. So in the aqueous layer, what will be there? In the aqueous layer, there will be the sulfonamide of primary amine. That sulfonamide primary amine will form one salt, that will be in the aqueous layer. And in the upper organic or ether layer, there will be the tertiary amine, that is not reacting with the Hinsberg reagent, and sulfonamide of secondary amine will be in the organic layer. So these two layers are separated by separating funnel. If we open this knob, then these two layers we can easily separate by the separating funnel. Okay, and tertiary amine is obtained by fractional distillation of the ether layer, and the other fraction that containing the sulfonamide of the secondary amine is treated with concentrated HCl. Then secondary amine, that is the secondary amine hydrochloride, that will be formed. Okay, and the secondary amine hydrochloride on distillation with NaOH, that will yield the secondary amine. So in this way we can easily separate the primary amine, secondary amine and tertiary amine, and this method is known as Hinsberg method. Okay, and the aqueous layer will be acidified with dilute HCl. Okay, the aqueous layer, there will be the primary amine. Okay, primary amine sulfonamide salt, that we have to acidify with dilute HCl, and then it will be hydrolyzed with concentrated HCl. Then that the hydrochloride of the primary amine we have to distill over NaOH, then we will get the primary amine free. Okay, so in this way, from the aqueous layer we will get the primary amine, and from this organic layer we will get the secondary and tertiary. Other methods are also available. We can do fractional distillation, as their boiling points will vary. Okay, there is large difference, and Hoffman's methods also we can apply here. But this Hinsberg method is in your syllabus, so this is very important for your exam. So today, up to this, thank you very much.